there's a collection of curves that come up again and again in applications, both mathematical and physical. And it turns out that all of these curves come from taking a cone and just slicing it. Here's a cone, and it turns out that what you really want to do is have two halves of a cone. So here we have a collection. This cone is made up by a collection of rays emanating from this point A. But why have rays? Why have just half the lines going up? Why not let the lines go up and down? If you do that, you get what's called a double cone, which looks like this. The upper part is called the upper nap of the cone, I think N-A-P-P-E, and the lower part is the lower nap. And all of these shapes come from cutting through this double cone at various angles. So to see what that would look like, let's get a plane. So I can control the angle of this plane by moving this point over here. You can see the plane moves around. And just to make the intersection of the cone and the plane easier to see, I'm going to highlight it in black. So every curve we get by intersecting the cone with this plane, we're going to call a conic section because it's the section of a cone. You can see that this conic section that we get by slicing the cone with a horizontal plane, it looks like a circle, and indeed it is a circle. If you slice a cone perfectly horizontal, you do get a circle. We can see that circle by looking at this cone from directly above. So there's the circle that you get as a conic section. All right, so now let's change the angle of this plane. We'll start just by tipping it upwards a little bit. And when you tip the plane upwards a little bit, the circle kind of gets stretched along one axis, and you get this sort of oval shape. It looks as if maybe you could make it look exactly like a circle from some angles, but that's just a perspective effect. If you looked at this flat plane sort of from a perpendicular angle, the curve looks like this, and you can see it's not circular. It is stretched out in one direction. So that shape is called an ellipse. So an ellipse is a conic section. Now, the more we tip this plane upwards, the longer the ellipse gets, until at a certain point, you have to imagine that this cone extends infinitely up. So it doesn't have this flat top, but just keeps going up and up and up. But at a certain point, the plane will actually be parallel to the side of the cone. And if the plane is parallel to the side of the cone, then this ellipse, or this conic section, never really closes up, right? As long as this angle is lower than the side of the cone, the conic section is going to sort of pop out the other side of the cone at some point and close up into an ellipse. But if we make the plane parallel to the side of the cone, this conic section that we're getting never actually closes up on top. Remember, we have to imagine that this cone goes up infinitely far, so this top line segment isn't actually there. So in this configuration, with the plane parallel to the side of the cone, we get this kind of shape that just keeps going up and up and up and never pops out of the other side of the cone, so it never closes back up. This shape, it turns out, is called a parabola, and yes, that is the same parabola that you're used to graphing from algebra classes you may have taken. All right, so far the conic sections that we have gotten are a circle when the plane is horizontal, an ellipse when the plane is at a small angle, we get a parabola when the plane is parallel to the side of the cone. Now when the plane keeps tipping up past the parabola, eventually it intersects not just the top part of the cone, but also the bottom part. And so we get this shape that kind of looks vaguely parabola-like, except it sort of opens too far for a parabola, and it also has this second piece at the bottom. It's not clear from this picture, but in fact, these two parts, the upper part and the lower part of the intersection, are exactly the same shape. These two pieces together are called a hyperbola, and that's the last conic section. There are actually a few other degenerate conic sections you can get by slicing this cone in very special ways. You can get a line if you slice the cone parallel through the center along one of its sides. You can get just a point if you slice directly through the center of the cone. But ignoring those degenerate conic sections, the full list of conic sections are circles, ellipses, parabolas, and hyperbolas.